Hello, my topic for today is to tell you about Web Audio API. So I'm about to tell you what it actually is, how it works, and how to implement it into your website. First, let me tell you what it actually is. So Web Audio API is a tool that helps developers to somehow edit audio content on their web page, add some effects on it, and to output it onto computer speakers. So Web Audio API, its concepts. The first thing you have to know about Web Audio API is that it constructs from modules that are called audio nodes. These audio nodes are combined together with connections. They are connected to each other, building an audio routing graph. This structure is really comfortable and convenient for developers because you can put something away from this graph or add it, and it's actually easy to work with and really comfortable to edit audio content on your web page. So to tell about audio nodes, what it is, it's modules that can represent source from your audio, its effects and output. Source is the thing where you take your audio from. It can be from microphone of your computer, it can be from audio file, it can be from HTML page, from text, audio and video and so on. Effects, well, it's effects that you apply to your audio you're taken from source. It can be gain, delay, so on. And output, which is a place where you output your audio. As I said before, it's almost in all cases speakers of computer. So sources, the place where you take audio from. It represents array of samples per unit of time, and as I said here, for example, with sampling frequency of 44,100 Hertz in each second of each channel, it will be 22,050 samples. These audio sources, I said before, can be generated and created mathematically using oscillator node, which is a special audio node module. Can be read from audio video files and can be from audio flows, which is from your, for example, web camera or microphone. So now let's talk about how to build your how to work with Audio API in common. First thing you have to do is to create audio context. Audio context is the thing that is responsible for all audio manipulations on your web page. Then inside it you have to define your source, as I said before, what it can be, your effects, your final video audio output, and then join them together so it could work properly, and that's all. So one more thing about Web Audio API is why it is so comfortable, because it is capable to work with your audio depending on time. So for example, you can add an effect on your audio since for example your audio plays, it comes for 3 seconds, and then you enter your effect. It can be very easily done, and I will show you how next. So let's move on, and I will tell you now about Web Audio IP interfaces, about what is audio context, what is audio nodes, and so on. There will be definitions. So Audio API contains 28 interfaces and appropriate events, and I grouped them to some groups for more comfortable understanding them. So the first group is main audio defining objects. It's the general thing you have to know to somehow work with Audio API. So here you can see audio context. Audio context is audio processing object, as I said before, which is responsible for all manipulations with your audio. You create audio context by using for example, const name of your audio context equal new audio context is a class. So Okay, and you create audio nodes inside this audio context. Now let's talk about what audio node is. Audio node is an audio source, audio processing module, which is effect, or your final audio output. As I said before, it can be all of these three things. I will show you on an example so you could understand it more properly. And audio param. Audio params is things that are passed into audio nodes. Audio node, for example, effect gain. It has property gain, which is volume of your audio, and this property is an instance of interface audio param. So audio params is just parameters of audio nodes. And ended as general, it is event which is called when your audio has ended. Why it is needed? Because it's more comfortable to work when you know when your audio ended and to somehow do something after it ended. Then let's talk about audio sources, the places where you take your audio from. Audio nodes that are responsible for taking audio from somewhere is, for example, oscillator node. Oscillator node is a generator that generates your audio by a sine wave source. It takes frequency and tone. You set frequency parameter of that sine wave and its tone, and the oscillator generates sine wave according to these parameters. Then audio buffer. Audio buffer is a short audio sample which is stored from memory and read from audio file. Just an audio node that takes audio from your audio file. Then there is audio buffer source node. It is an audio node that stores your audio file read from the file and taken from audio buffer. Nothing really interesting here. And media element audio source node, and the next one is media stream audio source node. These two nodes are quite similar. Media element audio source node is an audio node that reads audio from your HTML file, text like audio and video. It reads audio from this text. And media stream audio source node is an audio node that reads information from your flows like web camera and microphone. So next let's talk about audio filters or effects that you can apply to your audio. The first is big-watt filter node. It is an audio node that can apply very simple effects to your audio, such as equalizer or tone controller. You can edit your equalization or tone with this filter. Then it is delay node. Delay node creates delay between your input. So it is, to explain you more properly, imagine a delay node as an object which takes input from audio and releases audio. So it creates a delay between the audio which is inputted and outputted, just a delay. So then gain, I've mentioned it before, it edits your volume. So it can make your audio louder or quieter. Also nothing complicated here. Then let's talk about your audio destinations or outputs. It's the places where you output your audio. Here is a quite simple example, is audio destination node. It's just a place where your output where your audio will be outputted from your audio context. It's usually, as I mentioned like 2 or 3 times before, it's system speakers. Then let's talk about data analyzation. The first 3 groups that I mentioned, it's sources, effects, and outputs, are 3 groups that are really important in working with audio API. And now this group, data analyzation and the further, are not really so important to know them, but it's also quite interesting. So data analyzation. It has analyzer node. Analyzer node is an audio node that can help you to somehow visualize your audio, like when let me tell you one example. For example, you read audio from your computer microphone, and when it's louder you can create an object that's background color ranges from red to green, and when the audio is louder it is red, and when it's low it's green. Kinda complicated, but I will show you how it works further. What is special about this analyzer node is that it is providing you a frequency of your audio and its time domain in a real time, which means while your audio is playing, it can give you its frequency and so on, which is really comfortable. Then audio spatialization. What about this group? This group of nodes is responsive for where your audio source is placed around your user of your web page. For example, when you sit in your headphones, you can hear sound with your left ear or with your right ear, and this audio spatialization group is responsive for this thing. It has audio listener node, which is an interface, which interface is representing the position of your user listening to an audio, where it will be located according to your audio, and panner node, which is responsive for your audio movements. For example, your sound can move from your right side to your left side, and so on, and also where it is located. Now, when I've told you about all these interfaces, let's go to an example, and I will show you now how to create a very simple program with Audio API. So, the first thing you have to do when you are working with Audio API, as I mentioned before, it's creating audio context. So we do it with this code, const audio context, new audio context. You can see it here. So then we create audio source. Now we will take the place where we now let's create the thing where we take our audio from. You can take it from your HTML page, from text, audio, video. You can read it from your web camera or from microphone and so on, but now we'll use oscillator. Oscillator, as I mentioned before, is an audio node that generates sine wave sound with given frequency and tone. So we create the first oscillator, writing const oscillator, and we apply this method create oscillator to our audio context. Then we set the frequency of our oscillator. We take this object oscillator, its frequency property, and the method set value at time. Why we use this strange method? As I mentioned before, Audio API is a really comfortable thing because you can add objects and properties according to time of your audio. For example, it can pass 3 seconds after your audio started, and then you will set, for example, oscillator frequency at the certain value. So let's see what we're doing here. We take this number. This number is the value that we give to a frequency of our oscillator. It means our oscillator will generate the sound at this given frequency, and this second number that we give to our method, 0, is the amount of seconds that come after our audio started. So it means that our oscillator frequency is set to this value after 0 seconds from the audio started, which means from the start. Then we create our effect. We will make a gain effect in this example. Why gain? Our oscillator that we created before generates the sound and at a very high volume, very loud. So we put our gain to lower this noise. So we create our gain controller and write it into a variable created by using method create gain to our audio context, and then set property gain of our object, and also use this method set value at time. I've said before how it works, and we set our gain value 0.5 since 0 seconds from the audio started. Then we do not create anything, we connect these modules. So let's see what we have done. We have defined an audio context. Let's imagine it as some canvas. We have made an oscillator which generates our sound. Then we have created our gain effect, and we have our output here. So we have to connect them all together, and let's see what we are doing. We are taking our oscillator and connect it using method connect to our gain controller. So the audio from our oscillator comes to gain controller, and it lowers its volume. I've explained that before. So then our gain controller connects to our audio context destination, which is my computer speakers, and it means that volume edited in gain controller comes then into our audio context destination, into our computer speakers. And then it seems that we have connected all these things, they have to work properly, but we don't hear anything. Why this happens? This happens because oscillator, we have told it how to create its sound and by which parameters, but we didn't tell it when to start. So we tell our oscillator to start generating sound using method start, and then we use method stop. Why we use it? Because if we just tell oscillator to start, it will generate sound endlessly. And to somehow stop this section, we add this stop method. Stop method works pretty simple to set time out from core.js, and it takes our audio context current time, which means the time when we started our audio, which is this moment when we put this start method, and then adds to it 0.5, which is 0.5 seconds since audio started. And since this time, our oscillator stops generating sound. So this was the instructions how to create our app, and now let's see how it actually works, and if it actually works. So I have created this wonderful button here, and I have the code that I put it into. First we read our button, add event listener click, and then all the code that I have explained before. And now let's see how it works. We've heard that after we press this button, our oscillator generates sound at this given frequency. Then we have our gain controller that sets that is lowering value in a half, 0.5, and then we output our edited audio into our audio context destination. So it works like this. Yeah, that's all that I wanna give to you, and now let's see what sources I used. This is main documentation, cool demonstration how frequency work, about how this sine wave is generated, and video guide where just a guy sitting and explaining how to create your web audio API app, as I did before. And also there are some cool websites that use web audio API, such as Web Audio Playground, Web Violent Theremin, and Voice Change-O-Matic. I will now go to this website to show you how Web Audio API works, but with visualization. So let's see what we have done just before. We added our oscillator. Here it is. Set its frequency to 260. Let it be this value. Then we added our gain node, and we set our gain node to 0.5. Then we connected our oscillator to gain and gain to our output. And then we told our oscillator to start generating sound. Then the sound goes to gain, and gain goes to our output. Let's see how it works. As we see, oscillator generates this sound endlessly. So to stop it, I press this button, oscillator stops, and that's how this program works. So that's all that I wanted to tell you. Thank you for your attention. I really hope you enjoyed my presentation.